Welcome to another video of thematic lectures. This is also a video from the series of doubt clearance sessions itself, October 2022. The section B question, that is question number 12. So in this question, a cylinder contains oxygen gas. So this cylinder contains oxygen gas at a temperature of 25 degrees Celsius. The temperature is 25 degrees Celsius. And the pressure in this is 1.4 times 10 to the power of 7 Pascal. The density of oxygen gas in the cylinder, that is what we really want to calculate. Calculate the density of the oxygen gas in the cylinder. So how will you do this question? So we have some we know some background information. What is basically density? Density is mass of this gas in the cylinder over volume of the gas in the cylinder. So we should separately calculate the mass and volume. So here the mass of this gas is unfortunately not given. Apart from that, the volume is also not given. Am I right? Don't get confused with this mass. This is what? One information is given, but it is not actually, not so worthy to directly substitute. But it is worthy, so we can use this to find the mass. How? Mass of the oxygen molecule. One oxygen molecule is 5.3 into 10 to the power of minus 26. So we can just assume that let this gas contains n number of molecules in the cylinder. So therefore, what will be the total mass? The total mass, we can say that the total number of molecules in this cylinder multiplied by mass of one such a molecule, that is mass of oxygen molecule. So that means n multiplied by the mass of oxygen molecule is given, that is 5.3 times 10 to the power of minus 26. Now, how will you find the volume? There is no clue given about volume, but you can find volume using this additional information given. The temperature and pressure of this cylinder is given, correct? So we have this another equation, P times V is equal to number of molecules times Boltzmann constants times the temperature. So from this you can calculate the volume, that is N times K times T divided by P. So we can use this idea here. The density is mass. Mass is n times 5.3 times 10 to the power of minus 26 upon the volume is n times K times T divided by the pressure. Any questions? No, right? Then you can cancel this n and n from this, and this pressure will be going to the numerator by applying the basic idea of algebra, that is pressure multiplied by 5.3 times 10 to the power of minus 26 divided by K times T. The pressure is given, so make sure that we are using the proper unit. Yes, it is given in Pascal, so we are 100% confident to use that value. So plug the value 1.4 multiplied by 10 to the power of 7. Then 5.3 times 10 to the power of minus 26 upon, what is K? You can use the value given in the question paper. At the end of this end page, you can see the value of the Boltzmann constant. So if you are referring that value, we can say it is 1.38 times 10 to the power of minus 23 is the value of K. Now, temperature. See, the temperature has to be in Kelvin. So here the temperature is given as 25 degrees Celsius. So this is 273 plus 25. So it is 298 Kelvin. So here we should apply that value, 298. So if you are plugging all the values, and if you're inputting, if you are plugging all these values in a calculator, you will get nearly 180.4 kilogram per meter cube as the density of this oxygen in this particular cylinder. Hope you got that idea, right? So this is the answer for question number 12. Any confusions? No, right?